Hello, my name is Muhammad Al-Nawawi bin Nasri and my matrix number is B132410-687.
Hello, my name is Mervin Son of Wasu and my matrix number is B1324-10691.
Hello, my name is Nur Afika Fitri binti Idi Fitri and my matric number is B132410-359.
Okay, so for the abstract, this project proposes a complete instrumentation plan for a closed circuit horizontal water channel used to test flow around an aerodynamic body. The working section is 8 meter long with a 0.9 meter times 0.5 millimeter cross section and 25 millimeter of transparent acrylic walls. The proposed hydrosite setup combines an inline electromagnetic flow meter for bulk flow rate measurement with particle image velocimetry, which is PIV, for quantitative flow visualization around the aerodynamic body, and dye injection is retained as a low-cost qualitative backup technique.
Moving on, let us look at the core objective of this project. Overall, we have established 4 key objectives to guide our study and ensure the success of this experiment. Our first objective is to measure the bulk flow rate and subsequently determine the average water velocity within the test section. The second objective focuses on fluid behavior visualization. We aim to visualize flow separation, wake formation, and water structure development around the aerodynamic body under test. Next, our third objective is to minimize flow disturbance inside the transparent working section. This is crucial to ensure that our visual data remains accurate and unaffected by secondary flow effects. Finally, the fourth objective is to choose an arrangement that meets practical criteria. Specifically, the setup must be feasible, safe, repeatable, and above all, suitable for student laboratory use. By aligning our framework with these 4 goals, we ensure that our experimental approach remains both rigorous and safe.
First of all, let's talk about how a turbine flow meter works. A turbine flow meter is inserted in a pipe directly in the flow path. The mechanical part of the turbine flow meter has a turbine rotor placed in the path of a flowing stream. The only moving part of the turbine meter is the mechanical rotor. The rotational speed of the rotor depends upon the flow velocity. The rotor blades are usually made of stainless steel. As the rotor spins, the passage of each rotor blade past a pickup point will generate an electrical pulse. The electrical pulses are created in different ways, depending upon the rotor blades themselves and the pickup unit characteristics. In most turbine flow meters, magnets are fitted to the blades, and a magnetic pickup sensor is used to create the pulses. The higher the rate of flow, the faster the rotor turns, and the greater the number of pulses.
Now, how does electromagnetic flow meter work? As you can see from the picture, that mag flow meter has two exciting coils. These two exciting or field coils generates constant magnetic field. And liquid flowing through the pipe act as conductor. When conductive liquid such as water flows through the pipe or tube, the magnetic field applies force to the charged particles. And it induces voltage. And this induced voltage is detected by two sensing electrodes, which are mounted in mag flow meter body. This induced voltage E is proportional to B, V, L. In this equation, B is magnetic field strength, V is the velocity of conductor, and D is the length of conductor.
Stop filming.
In conclusion, the most suitable instrumentation plan for our horizontal water channel is the combination of the inline electromagnetic flow meter and the two DPIV system. The flow meter is used to measure the flow rate accurately, while the PIV system helps us visualize and analyze the flow behavior around the aerodynamic body. This setup is suitable because it does not disturb the flow inside the transparent section, and fully utilize the arcade wall for optical measurement. As an additional method, dye injection can be used as a low-cost backup to observe flow pattern visually. This combination provides accurate measurement, clear flow visualization, and a particle solution for our experimental setup.